Hello viewers, this is Mahmood, and in this video we are going to solve some questions related to limit, continuity and derivatives. So the first question is calculate the limit value, that is part A, and here we have limit x approaches to 3 and the function is 4 times x negative 12 divided by x to the second power minus 9. So we are going to apply the limit directly. So that would become, 4 times 3 minus 12 divided by 3 squared minus 9. So simplify this fraction. That would become, 4 times 3 is 12 minus 12 upon 3 squared is 9. So 9 minus 9. And that gives us 0 over 0 form. Got it? So in order to find the limit, what will we do? We have to factorize both the numerator and the denominator. So you can see here that is the limit x approaches to 3. The numerator is 4 times x minus 12 upon, and the denominator is, that is x squared minus 9. So here we have the limit x approaches to 3, and you can see in the numerator we can take 4 as a common factor, so we left with x minus 3 divided by, and in the denominator this can be written as x squared minus 3 squared. 3 squared is going to be equal to 9. Okay, so now again the limit x approaches to 3, and here we have 4 times x minus 3 over, we have to use a formula here, and that is, that a squared minus b squared can be written as a plus b times a minus b. So here we have, instead of a we have x, and instead of b we have 3. So this x squared minus 3 squared can be written as x plus 3 times x minus 3. Got it? So now you can see here this x minus 3 will cancel out with the below x minus 3. So we left only with, that is the limit x approaches to 3. In the numerator we left with 4, and in the denominator we left only with x plus 3. Is it okay? Now we are going to apply the limit. So here applying the limit. So it would become, 4 divided by, we have to replace x by 3. So that is 3 plus 3. So the final result is going to be 4 divided by 3 plus 3 is 6. When we simplify this fraction, so that would become 2 upon 3. So we can say that the limit of the function when x approaches to 3 is 2 upon 3. That is, the limit x approaches to 3, the function 4x minus 12 upon x squared minus 9 will approach to 2 upon 3. Is it okay? Now move to the next question, that is part B. And here we have the limit is approaching to x upon 5, and the function is, that is 2x minus 10 upon x squared plus 25. First we have to apply the limit directly. So that is going to be, we have to replace x by 5. So that would become 2 times 5 minus 10 divided by, 5 squared here. So 5 squared plus 25. So now the numerator would become, 2 times 5 is 10 minus 10 divided by, and the denominator would become, 5 squared is 25 plus 25, and that would become 0 divided by 50, and we know that 0 divided by 50 is 0, and we can see that the limit exists. 0 is a defined value, so we can say that the limit of the function when x tends to 5 is 0. That is, limit x approaches to 5, 2x minus 10 upon x squared plus 25 is 0. Okay, now move to the next question. That is part C, and here we have limit x approaches to 1, and the function is x squared minus 1 upon x to the fourth power minus 1. So here we are going to apply the limit directly. That is, we are going to replace x by 1. So that is 1 squared minus 1 divided by 1 to the fourth power minus 1. So that can be written as 1 minus 1 divided by 1 minus 1, and that is going to be 0 divided by 0 form. So that is 0 upon 0 form. So in order to find the limit of the function, so what will we do? We have to factorize the numerator and the denominator as well. So that is limit x approaches to 1. The function is x squared minus 1 upon x to the fourth power minus 1. Here it can be written as limit x approaches to 1, x squared minus, this 1 can be written as 1 squared divided by, and in the denominator this x to the power 4 can be written as x squared to the power 2 minus 1 squared. Okay, so now that is going to be limit x approaches to 1. The numerator is as it is, that is x squared minus 1 squared. Now we have to apply a formula with the denominator. So we know that is a squared minus b squared can be written as a plus b times a minus b. Okay, so here in the denominator, instead of a we have x squared, and instead of b we have 1. Okay, so we will use the formula, that is a plus b. So a is x squared, b is 1, so plus 1, and a minus b, a is x squared and b is 1, so that is minus 1. You got it? So you can see here x squared minus 1 squared, 1 squared basically is 1, so x squared minus 1, x squared minus 1 will cancel out with the denominator x squared minus 1. So we left only with, that is limit x approaches to 1. In numerator we left with 1 divided by, and in the denominator we left only with x squared plus 1. Okay, now we have to apply the limit. So that would become 1 divided by 1 squared plus 1, and that would be 1 divided by 1 plus 1, and then this will become 1 divided by 2. So the limit of the function when x tends to 1 is 1 upon 2. That is, the limit x approaches to 1, x squared minus 1 upon x to the fourth power minus 1 is going to be equal 1 upon 2. Is it okay? Now move to the next question. Here we have a function that is f of x equal 3 times ax when x is less than or equal to 2, and x squared plus 1 when x is greater than 2. It means that it's a compound function. Okay, it's a compound function. And now find a, we have to find the value of a so that the function f of x is continuous. Okay, and we know that a function is continuous at a point a. We know that a function is continuous at a point x naught if the limit x approaches to that point x naught, f of x must be equal the function value at x naught. Okay, so here we have a piecewise function, a compound function. So here we have to check the left hand limit as well as the right hand limit at a point 2, because on the left side of 2 or on 2 the function is 3 times ax, and when the x is greater than 2, it means that when the domain is on the left side of 2, on the right side of 2, the function is x squared plus 1. So here we have to find the limit, that is the limit x approaches to 2 f of x. We are going to find this limit. And this limit only exists when the left hand limit equal the right hand limit. Okay, so let's say this is my left hand limit, and on the other side here we have the right hand limit. When x is greater than 2, so we have to use the right hand limit, and when x is less or equal to 2, we have to use the left hand limit. So that is going to be the left hand limit is limit x approaches to 2 on the left side, that can be written as 2 to the superscript negative sign. This shows that we are approaching to 2 on the left side. So that is the limit x approaches to 2 on the left side. And what will be the function? When we are approaching to 2 on the left side, so the values of x are less than 2. So we have to use the first function, that is 3ax. Okay, so that is 3 times ax. So here we are going to apply the limit. So that would become 3 times a into 2, because we are applying the limit x approaches to 2. So we get here 6a, and this is basically the left hand limit. Got it? And on the same way, the right hand limit, so that would become limit x approaches to 2 on the right side. So just for the notation, we have to write a positive sign on the superscript of 2 and the function f of x. So here the limit x approaches to 2 on the right side, and what will be the function? The function will be x squared plus 2, because we are approaching to 2 on the right side. So that is x squared plus 1. Now here we have to apply the limit, so that is 2 squared plus 1, and that is going to be 4 plus 1, that is 5. So the limit, the right hand limit, that is limit x approaches to 2 on the right side of the function f of x is 5. The limit only exists when the left hand limit equal to the right hand limit. Okay, it means that the limit x approaches to 2 from the left side, that must be equal to the limit x approaches to 2 from the right side of the function f of x. So here we have, what is the left hand limit? That is 6 times a. That must be equal. What is the right hand limit? That is 5. Okay, so the value of a is going to be 5 divided by 6. So when we put a is equals 5 divided by 6 into the piecewise function, so at that time this function is continuous at a point 2. Okay, so we can say that for value of a, so you can say hence for a is equal to 5 divided by 6, the given function f of x is continuous. Okay, now move to the next question, that is find the derivative of these functions. So the first function is that is f of x equal x to the power 100 minus x to the power 50, then plus x to the power 10 minus 12,345. This is our function, and we are trying to find the derivative of this function. So we have to differentiate this function with respect to x. That is, differentiate with respect to x, because here x is the independent variable. Okay, so that is going to be d over dx of the function f of x is equal, we have to apply the derivative here also, that is x to the power 100 minus x to the power 50 plus x to the power 10, and then minus 12,345. And on the right side, on the left side, the derivative of the function f of x can be written as f prime of x. Okay, this is just the notation. F prime of x means the first derivative of the function. Okay, now we have to apply the sum rule here. The derivative will apply with every term of the function. Okay, so that is the derivative of the first term x to the power 100, then minus the derivative of the second term, that is x to the power 50, then plus the derivative of the third term, that is x to the power 10, then minus the derivative of the last term, that is 12,345. Now here we have to use the power rule. What's the power rule? That is when we apply the derivative on x to the power n, so that would become n times x to the power n minus 1. Okay, this is what we call the power rule. We have to multiply this power, the power multiply with x to the power n minus 1. We have to subtract 1 from the power. So this is what we call the power rule. So here you can see instead of n we have 100 here, so we will multiply the 100 with x to the power 1 minus from the 100, that is 100 minus 1. Got it? In the same way here we have to multiply this 50 with x to the power what? 50 minus 1. The same way here x to the power 10 the derivative of this would become 10 multiplied by x to the power 10 minus 1. Okay, and you know that the derivative of any constant is 0, so the derivative of this constant is 0. So the final derivative of the given function is f prime of x equal 100 times x to the power 100 minus 1 is 99 minus 50 times x to the power 50 minus 1 is 49, and then plus 10 x to the power 10 minus 1 is going to be 9. So this is the derivative of the function. Got it? Now move to the second part of the question, that is part B. The given function is g of x equal 3 divided by x to the power 3, and then plus cube root of x. Okay, first we are going to simplify this function, that is g of x equal, the first term can be written as 3 multiplied by x to the power negative 3, and then plus this cube root of x can be written as x to the power of 1 divided by 3. Now we have to differentiate this function, that is differentiate with respect to x. Okay, so that is derivative of d over dx of g of x is equal the derivative of the right side, that is 3 times x to the power negative 3 plus x to the power 1 by 3. Okay, on the left side that can be written as g prime of x, and on the right side we will apply the sum rule of the derivatives. It means that we have to apply the derivative with the each term of the given function. So that is the derivative d over dx applied with the 3 x to the power negative 3, then plus the derivative of x to the power 1 upon 3. Again here we will use the scalar multiple rule as well. So that is, this scalar 3 will come out from the derivative, so that is 3 into derivative of x to the power negative 3, and then plus the derivative of x to the power 1 upon 3. Here we are going to apply the limit and apply the derivative, and we will use the power rule again. So here the 3, and you can see here we have to apply the power rule here. So this power negative 3 will multiply with the x to the power negative 3 minus 1, and the same way here, plus this power 1 upon 3 will multiply x to the power 1 upon 3 minus 1. Okay, so now you can see here we will multiply this inside, so that would become 3 times negative 3 is going to be negative 9, and x to the power negative 4, and then plus 1 upon 3 x to the power 1 upon 3 minus 1 is going to be negative 2 upon 3. Okay, now we have to simplify this. You can see here that is the g prime of x is equal, this first term can be written as negative 9 upon x to the power negative 4 would become x to the power positive 4, plus 1 divided by this can be written as 3 into cube root of x squared. Okay, so this is the final derivative of the given function. Is it okay? Okay, now move to the next question. That is, you know, at a time t is greater than or equal to 0, the speed of an object along a horizontal axis is given by the velocity equation, that is v of t equal t squared minus 4t plus 4. That is, the velocity function is v at the time t is t squared minus 4 times t and then plus 4. Okay, so first part of the question says find the object's acceleration when the speed is 0. Okay, when the speed is 0, find the object acceleration. Okay, so now first we are going to find the value of t. When the speed is 0, when the speed is 0, it means that v of t equals 0, but v of t is equal to t squared minus 4t and then plus 4 equal 0. So here, this is a quadratic equation you can see here. So we have to factorize this. So that is going to be t squared. And minus 40, you can see here the product is 4 and the sum is negative 4. So what will we do? We have to minus 2t and plus 4 equal 0. So we have to take common t from the first two terms, so that would become t minus 2. We have to take negative 2 as a common, so that would become t minus 2 again equal 0. Now you can see here t minus 2 is again as a common factor, so that is t minus 2 and then t minus 2. We left t minus 2, you can see here. That is going to be equal to 0. So you can see here that would become, t minus 2 equals 0 or t minus 2 equal 0. So we got two same values, the roots are, same, or you can say repeating. It means that the velocity is 0 when time is 2. Okay, so now we are going to find the object's acceleration at this t is equal to 2. So now how to find the the acceleration? So our velocity function is v of t is equal t squared minus 4t plus 4. Okay, now the derivative of the velocity function gives us the acceleration function. Okay, so now in this case t is the independent variable and v is the dependent variable, so we need to differentiate this function with respect to time, that is t. Okay, that is differentiate with respect to t. So that is going to be d over dt of v of t is equal the derivative of the right hand side, that is d over dt into t squared minus 4t and plus 4. And on the left side, that can be written as v prime of t, and that is v prime of t is basically the acceleration. So instead of writing v prime of t, we have to write a of t. Here a is basically represent the acceleration of the object. So a of t equal, here we are going to apply the derivative with the every term, that is what we call the sum rule, that is d over dt of t squared minus, here when we apply the derivative with 4t, so again we have to apply the scalar multiple rule, so this is scalar 4 will come out from the derivative, so that is d over dt of t and plus the derivative of 4, so that is d over dt of 4. So the acceleration at time t equal, here we have to use the power rule, that is the derivative of t squared is going to be 2t minus 4, the derivative of t is 1, okay, and the derivative of 4 is going to be equal to 0 because the derivative of the constant is 0. Is it okay? Now we have the acceleration, that is a of t equal 2t minus 4. So now we need to put the value of t here. So that is when t is 2, the acceleration at this point 2 is a of 2 is equal 2 times 2 minus 4, and that would become 2 times 2 is 4 minus 4, that is 0. We can say that the acceleration at time t is equal to 2 is 0. Got it? So now move to the next part, that is part B. When does the speed increase? When does the speed increase? So the answer is, uh, velocity increases when acceleration is positive. It means that the speed is increases when the acceleration is positive. We're going to do the part B here. The answer is, uh, velocity increases when acceleration is positive. Okay, that is, that is a of t is greater than 0. So a of t is greater than 0 means velocity is greater than 0. And we know that velocity is basically this one, that is a of t is equal to t minus 4. So we have to replace a of t by 2t minus 4, and that is greater than 0. Now we have to solve this inequality for t. Okay, so that would become 2t is greater than 4. So here we are going to divide by 2, so t is greater than 2. So here, when the time is greater than 2, acceleration will be positive, and when acceleration is positive, velocity increases. And obviously when velocity increases, the speed increases. Okay, so the answer is velocity increases when acceleration is positive, and then velocity increases for hence velocity increases for t is greater than 2. Is it okay?